Hello, good morning, everyone.
Morning.
I would like to invite all the. Hello, good morning, everyone.
Good morning.
Morning.
I would like to invite all the. Hello, good morning, everyone.
Good morning.
Morning.
I would like to invite all the. Hello, good morning, everyone.
Good morning.
Morning.
I would like to invite all the. Hello, good morning, everyone.
Good morning.
Morning.
I would like to invite all the. Hello, good morning, everyone.
Good morning.
Morning.
Morning, all. I invite you all the first international conference on applied science, business, and management, engineering, and technology, which is organized by Confold Education Research and Development Association (CERDA) in association with Dasmesh Khalsa College, DKC, Zirakpur, Punjab, India. This conference offers researchers, delegates, and scholars an incredible chance to interact with each other and share their experiences and knowledge, to engage in insightful discussions and share cutting edge research findings, advancements, and best practices in applied science, engineering and technology, business and management, education, social science and humanities, and more. About CERDA. The Concord Educational Research and Development Association is an internationally recognized, globally operating multidisciplinary professional research and development association. Concord Educational Research and Development Association aims to integrate researchers and academicians working into the micro disciplines of science and technology, fostering and collaboration and innovation across a broad spectrum of fields. Concord Education Research and Development Association dedicated to building a dynamic community of professionals, educators, researchers, and innovators in the realms of engineering, science and technology, business and management, social science and humanities, and education. Our forums and affiliates include distinguished professionals and organizations, all working together with a common goal to be champions of science, safeguarding the earth. CERDA provides a top-tier platform for scientists, researchers, academics, and business leaders by hosting conference and publishing groundbreaking research. CERDA conferences serve as a dynamic platform for experts and visionaries to advance the frontiers of education, engineering, and technology, social science, and humanities, fostering collaboration, innovation, and interdisciplinary growth. Happy to invite Dr. Divakar Ramanuj Tripathi, Department of Computer Science, SS Mania College of Computer Science and Management, RTM Nagpur University, Maharashtra. About Dr. Divakar Ramanuj Tripathi is currently serving as the head of the Department of Computer Science and Controller of Examinations at SS Mania College of Computer and Management, Nagpur, Maharashtra, India. He is also recognized as a PhD supervisor at Rashtrakan Tukadoji Maharaj Nagpur University and a visitor faculty member at ISBN University. With over 13 years of professional experience in the field of information technology, Dr. Tripathi brings extensive expertise in consulting, training, and IT management. His core competences include capability enhancement, enterprise analysis, and IT security and business analysis. He is an ISO certified lead auditor and a Microsoft certified technology specialist. Dr. Tripathi has contributed significantly to academic research, having published more than 20 research papers in reputed international and national journals and conferences, many of which are Scopus indexed and UGC approved. He holds over 10 national and international patents and has registered 11 copyrights. Additionally, he is a registered trademark attorney with the Government of India. He has been the recipient of over 12 national and international awards in recognition of the contributions to the field of computer science. Notable allocates include the Bharat Nepal Shiksha Vibhushan Award, the Innovation Research Award, and the Albert Einstein Award at the international level. Dr. Tripathi holds fellow membership in several esteemed professional organizations, including Institute of Research Engineers and Doctors, IRED, New York, USA, International Scientific Research Organization for Science, Engineering and Technology, Indian Academics and Researchers Association, IARA, Scholars Academic and Scientific Society, SAA Society. Now I welcome Dr. Divakar Tripathi to deliver his speech.
Hello, am I audible?
Yes, sir.
Yeah. So, first of all, good morning, everyone, distinguished speakers, delegates, and guests. I am Dr. Divakar Tripathi from Nagpur, Maharashtra, the conference chair. As we reconvene for the final day of our conference, it's my privilege to reflect on our shared journey and set the tone for the concluding chapter of the International Conference on Applied Science, Business and Management, Engineering and Technology. Yesterday, we explored a rich landscape of ideas ranging from engineering innovations to business strategies and technology adoptions. If we talk about some key highlights from the day one, it's an applied science breakthrough in renewable energy and smart materials, engineering excellence showcased through robotics and IoT systems, business and management insights into digital transformation and sustainable models, technology sessions on AI integration and data analytics. These sessions have not only provided us with knowledge but spark connections, debates, and promise of cross-disciplinary collaboration. Now, the day two, our objective of today's action is to synthesize across disciplines, dive into panels uniting engineering with strategic business thinking, expand the application scope, examine real-world case studies in sustainable infrastructure, Industry 4.0, and data-driven management, and finally collaborate for impact, seek our potential partners, academics, industry, and leaders, and policymakers to co-create future-ready solutions. Our aim is crystal. So let's today be the turning point where innovation meets the implementation. I urge each of you to engage courageously, step out of your comfort zone into complementary sessions. Ask the intentional questions to prove the practical applications and scalability. Propose the partnership, even a hallway conversations can spark research collaborations or startup ideas. If we talk about some key takeaways, it is an integrating applied science plus engineering plus business which empowers the innovations, especially in sustainability and social impact. Today's sessions on engineering in business strategies and technology for management excellence offer practical framework for these integrations. Your participations as a speaker, moderators, and attendees has shaped this event into a crystal for a change. So before we part away, let's commit to a few concrete steps. The first one is to follow through. Continuous conversation is part here. Share your outcomes, publish findings, buildings prototypes, and pitch solutions. And stay connected, leverage our conference network and digital platform to maintain the momentum beyond these walls. So, in my closing talk, I sincerely thank our keynote speaker for their inspiring insights, session chairs and reviewers for containing such high quality contents, organizing and support team for flawless executions, and each delegates for your curiosity and engagement and openness. Thank you, and my final day mark the beginning of impactful collaboration and innovations. Thank you. Thank you so much.
Thank you, Dr. Divakar Tripathi, sir. Next, I invite Dr. Anush Kumar Gupta, Director and Principal, CGC College of Engineering. About Dr. Anuj Kumar Gupta is working as Director Principal at CGC College of Engineering, Mohali, Punjab, India. He is a doctorate in computer science and engineering with a vast academic and administrative experience of 24 years. He has guided 27 PG and 10 PhD research scholars so far. He has published more than 120 research papers in reputed international and national journals and conferences. His area of research is wireless network and security. He has filed more than 10 patents with one patent granted and published 5 books. He is an active member of review board of Elsevier, IEEE, Springer, IGI Global, and many more reputed research agencies. He is a life member of Computer Society of India, ISTE, and many more.
Good morning, esteemed dignitaries, respected scholars, industry experts, and fellow innovators. It is both an honor and a privilege to address this distinguished gathering at the International Conference on Applied Science, Business and Management, Engineering and Technology. Today, as we stand at the confluence of rapid technological transformation and global aspirations for sustainable development, few topics are more compelling or consequential than AI, that is artificial intelligence. AI is no longer a futuristic concept. It is totally a reality, transforming industries, redefining human potential, and reshaping the global economy. From personalized healthcare and autonomous vehicles to predictive analytics in business and intelligent automation in engineering, AI has woven itself into the very fabric of our lives. Yet, with great power comes great responsibility. So today I will focus on AI, the challenges and opportunities, exploring the future of AI in a changing world. So first is, what is AI? Basically, AI refers to the ability of machines to stimulate human intelligence, including learning, reasoning, problem solving, perception and language understanding. Smartphones, social media, streaming services, healthcare, finance, transportation and smart homes are few examples that are running on the AI technology. So this is a brief history from Turing to deep learning. In 1940s, Alan Turing proposes the machine intelligence. Then in next 60s, rule-based system like ELIZA stimulate the conversation. In 1980s, rise of expert systems and early machine learning. 2000s, big data and compute era. 2010 to now, deep learning revolution is into existence and neural networks dominate. So current language AI is used in everyday life. Next is the types of AI. First one is narrow. It covers specialized tasks, for example, Siri, Alexa, Google Translate, etc. It is also known as weak AI. It refers to the AI systems that are designed and trained to perform a specific task or a narrow set of tasks. These systems operate under a limited set of constraints and contexts, unlike human intelligence, which is general and adaptable. Next form is general AI. It is human-like cognition, basically the theoretical concepts. It is also known as artificial general intelligence or AGI. It refers to the AI systems that possess the ability to understand, learn, and apply knowledge across a wide range of tasks, just like humans do. The third type is super AI, which is also known as artificial superintelligence. It refers to a hypothetical form of AI that surpasses human intelligence in every aspect, from creativity and problem solving to emotional intelligence and decision making. So these are the few opportunities, or we can say domains of AI across the industries. They are healthcare, automotive, manufacturing, energy and oil, education, hospitality, finance, retail and e-commerce, and logistics. So AI can analyze medical images, X-rays, MRI, CT scans faster. It accelerates the discovery of new drugs by predicting how compounds interact with diseases. Virtual AI tutors provide extra support outside classroom hours. AI-powered system can assess students' skills and interests to suggest suitable career paths. AI forecasts demand, managing inventory and supports optimal shipping routes. Uses computer vision, sensor fusion and deep learning for navigation and obstacle avoidance. So these are a few specific career paths in artificial intelligence. AI engineer, machine engineer, data scientist, AI research scientist, data engineer, and robotics engineer. These are the few economic and social benefits of AI: increased productivity, job creation in AI, data-driven decision making, accessibility improvements. So let's focus on the major challenges of AI. First one is ethical concerns, that is bias and accountability. Next is privacy, data use and surveillance, job loss, automation. Automation of routine and manual jobs can lead to mass unemployment of job shifts, especially in vulnerable industries. And security is also a major challenge. Cyber threats, AI weapons, overlap and control. Next is technical challenges. It includes data quality and availability, explainability, generalization issues, high computational costs. So AI systems require vast, high quality data sets. Issues mainly comprise of noisy, biased or incomplete data. Data labeling is labor intensive and expensive. Many AI models are black boxes, especially deep learning. It is difficult to understand how decisions are made, which affects trust and accountability. So this raises environmental and scalability concerns too. Next is ethical and social dilemmas, responsibility in AI failure, AI bias concerns, should AI have rights, and inclusivity in AI development. So who is to blame when AI makes a mistake? Lack of clear legal frameworks can cause AI harm. AI system can perpetuate or worsen existing social biases. For example, biased hiring tools, facial recognition inaccuracies. Facial recognition and tracking technology that operate without public consent. Most AI development is driven by a few tech companies in development countries. Global perspective on AI, US and China, they are the innovation leaders in AI. Then comes European Union, ethical focus on GDPR, and then developing countries, adoption hurdles are the major challenges. Challenges also include ethical regulation and public sector adoption, ethical and trustworthy AI, human-centric AI, slower commercial scaling compared to US and China, AI for agriculture, healthcare, education and infrastructure, limited resources, data infrastructure and talent retention. The future of AI is integration with emerging technologies, AI governance and regulation, human AI collaboration, risks and safety research. So AI plus quantum computing gives faster processing and better optimization. AI with IoT works smartly and gives us a reputed or high-tech infrastructure and smart cities and smart homes. AI plus robotics are more autonomous, adaptive system in real-world tasks. Future AI will be shaped by international law and ethical frames. Trends towards more responsible AI focusing on transparency, accountability, and fairness. AI will increasingly work alongside humans, work as co-pilot in creating technical and medical fields. So emphasis on augmenting, not replacing human intelligence. Focus on aligning super intelligent systems with human systems. Developing safeguard against unintended consequences or misuse. So these are the few AI future responsibilities. AI can work in the specific domains like automation, data dominance, personalized experience, enhanced decision making, ethical AI integration, cybersecurity advancement, smart cities of course, and intelligent healthcare as we discussed earlier. This is the future of AI in higher education. There are a number of domains that AI will cover. It will customize student support system, instruction facilitation, effective research work, predictive analysis, tracking students' performance, self-learning and various learning pathways. These are the ways that AI contributes to the education sector. Thank you very much. This is all I want to discuss today. I wish all the best to the organizers and keep learning. Have a good day. Thank you. Good morning.
Next, welcome Mr. Subhankar Panda, QA Project Manager, AI/ML Development, Emphasis Technos, USA to deliver his speech. Subhankar Panda is a seasonally quality engineering executive and AI/ML program manager with deep expertise in fintech, banking, and insurance. He leads transformative QA initiatives that use artificial intelligence, cloud technologies, and automation to enhance compliance, operational efficiency, and digital resilience. At Emphasis, Subhankar drives the quality strategy for AI-powered loan automation platforms, ensuring fairness, accuracy, and regulatory alignment. With a strong foundation in Azure Cloud, CI/CD optimization, and intelligent test frameworks, he is at the forefront of building secure and scalable digital ecosystems that define the future of smart finance. Now I invite Mr. Subhankar Panda to give his speech.
Thank you. Let me share my screen so you can see the PPT. Just let me know once you're able to see the screen. Are you able to see my screen?
Yes, sir.
Yeah. Hi everyone, this is Subhankar Panda. I am a qualitative engineer executive and AI/ML program manager at Emphasis. Today's topic is might sound bit different for you guys, like coming from someone a tech background, but that's the point. We are talking about the global food security, but through the lens of system thinking, innovation. In short, what tech and quality discipline can teach us about feeding the future. So the unseen challenges are a system perspective. Let's break it down. Okay. So food security means people are having reliable access to safe, nutrition food. Always sounds simple, but the system behind it are anything. But now think of a fintech, complex and multi-tiered, sensitive to failure. Food system are not the same. If you look at the data, 800 plus 800 million people go hungry every day. That's not just a humanitarian issue, that's a massive quality defect in the global system as well. Looking ahead to 2050 population will have 10 billion mouths to be fed, and we will be doing it while dealing with climate changes, resource scarcity and global conflict. We can't fix this with more of the same. We need a smarter system for that. So we do have four pillars. If you look at the quality framework, we have four pillars. Here, how do you approach through quality engineering mindset? Like the four pillars that what we are talking about. First thing is availability. Are we producing enough? Think seed innovation, genetic engineering, sustainable livestock. In tech terms, this is like ensuring computer power. You need to capacity before anything else. First, you need to check the capacity, all right? Now, coming to the second one is the access. Can people actually get the food? This is about logistics, storage, infrastructure, tech equivalent like data packets. No use generating data if it is never reached to the user. If you are generating data and it is not used by the user, the person, then there is no point, right? So coming back to the third point, stability. Can the system withstand shocks like climate events or market crashes? That's your economic buffers, climate adaptation, insurance mechanisms, all these will help. Now, the last pillar is utilization. Are people getting the right nutrition safely? This is food safety, nutrition standards like running a QA across the entire supply chain. Now, agriculture as a high performance system, we are applying high performance system concepts to farming. That means using genomics or CRIs, like we optimize the code, making crops stronger, more resilient. Precision agriculture with IoT, drones, and satellites. Basically, it's remote sensing and real time controls like we do in data centers in tech language. That's what we're supposed to do. Then AI driven decisions like predicting pest outbreaks, fine tuning irrigation, manage nutrition precisely. This is not hypothetical. This is happening, and it is not about more yield. It's about less waste, better ROI, and sustainable breakdown. Now coming to this, like engineering sustainable reliance designs. So basically is not about bouncing back, it's about bending without breaking. Okay, so in agriculture that means soil health. How is the soil health? No till farming, crop rotation to maintain biodiversity. Then second point would be water optimization. How do we use the water? Drip in irrigation is there. Smart sensor to avoid waste. Integrate pest management using biology, culture, and precision tools, not just chemicals. Adapt crops engineered to survive floods, droughts, and heat waves. This is preventing maintenance for the agriculture, not reactive firefighting. Okay. Now the last, how do you gonna implement the AI ML cloud frontier? So now we bring back the tech stack. How do you gonna implement that? Let's say predictive AI helps farmer to make proactive decisions like yield forecast, disaster alerts, pest warnings, and machine learning will help you to optimize the resource allocation, less input, more output. Cloud infrastructure like AWS, Azure, or GCP powers real-time farm analytics. So whatever means, it just give you the data like how the things has been done. And coming to the last one is the blockchain. It's about trust, transparent, verified food sourcing from farm to fork, right? the technology together. Now the last one is what is the challenge and investment path. So of course, innovation without responsibility is risk. So we need invest in AI and biotech, but guided by the ethical framework focused on nutrition, resilience, and equality. Policies need to be protect public interest without slowing innovations. Smallholders who feed much of the world need access to the small tools and data as large industrial farms. R&D department should be there, should focus on the automation, sustainability, accessibility. This is about the strength the entire chain, not just the top of it. Now, engineering in food secure future, let's wrap it up. Okay. So what we are really thinking about engineering food system, like we built tech system, scalable to meet the growing demand, intelligent to optimize resources, resilient to handle shocks and failures. This is not science fiction. The tools AI, cloud, blockchain, biotech are already here. What's missing is the integration and international design. We need to build a food networks that are protect, transparent and future ready. Now I'll pause here. If you have, I would love to hear your thoughts, question or even disagreement. Let's explore how the vision can be turned into a practice. But this challenge does not belong to agriculture alone. It belongs to engineering, policymaker and technology, all of us. Thanks for listening.
Thank you, Mr. Subhanga Panda. Next, I'd like to invite Dr. Surya as Assistant Professor, Department of BCA, SRM, IST, Ramapuram Campus, Chennai, India. About Dr. Surya is an accomplished assistant professor and former software engineer at Michigan Technologies. She excelled in mentoring and academic research, enhancing student success and academic rigor. Renowned for integrating technology and fostering interdisciplinary collaboration, my contributions to curriculum development and scholarly writing have significantly advanced educational quality and research excellence. Assistant professor with 6 years of experience successfully contributing to data science curriculum development and delivery, driven to contribute to program outcomes by facilitating engagement and supporting learning objectives. Enthusiastic professional with background in academic advisement. Enthusiastic assistant professor well versed in innovative teaching methods and machine learning, known for providing great support to both professors and students with approachable demeanor with excellent attention to detail, dedicated to classroom and long-term student success, professional educator with strong background in academic instruction and research, adept at fostering collaborative environments and driving impactful results, skilled in curriculum development, student mentoring, and scholarly publication, known for adaptability and reliability in dynamic academic setting. Now I welcome Dr. Surya to give a speech.
Yes, sir. Good morning, all. I'm audible, sir.
Yes, ma'am, audible.
Okay.
Please turn on your video, ma'am.
Okay.
Thank you.
So my screen is visible, sir.
Yes, ma'am.
Yes, sir. Good morning, everyone. I'm Surya, Assistant Professor from Department of Computer Science and Application, SRMIST, Ramapuram campus. Uh, it's my privilege to deliver you the session address here. So today I'm going to discuss regarding the power of data science, business intelligence, artificial intelligence, and analytics regarding. Is So the data science here, data science, business intelligence, and artificial intelligence, these three things are interconnected together, and it employs well to handle the data science operations. And we need to understand the difference between what is data intelligence, artificial intelligence, and data science. So based on that only, we can able to well into the correct descriptive analytics or what kind of analytics we need to go into. Yes, the human being, the visualization which plays a vital role because the human being mind can able to visualize the data, capture the visualize the data easily, and go through the insights on different basis. So we are going to see how the business intelligence and the artificial intelligence related and different in the data science fields. Based on the core objective, the business intelligence and data science here, there are two terms which are interconnected to the data with analytics. So here, business intelligence, it's most probably which focused on the historical data and data science, which beyond the beyond the descriptive analysis. So business intelligence, which gone through the historical data, and it will explain you how the historical data went, and how we are going to proceed, and what are the insights given. So it's like um, for example, monitoring the performance in organization, and what are the indicators which play a vital role, so that everything can comes under your business intelligence. But data science, which is beyond that, it's beyond the descriptive analytics, and it will give you the prediction and prescriptive analytics based on that data. So it consists of advanced statistical models and machine learning to perform the prediction, forecasting, and everything. So based on the core objectives, the business intelligence, which deals with the historical data, and it will explain regarding that what are all the factors affecting and how your performance is going on. Everything will comes under business intelligence. And in your data analysis, it's beyond the descriptive analysis, and it helps in forecasting the demand, and forecasting the upcoming things, etc. So this is based on the core objective. And moving to the data types and complexity. So BI, that's the business intelligence, which deals with the structured data. But data science in the another another thing, that the data science, which deals with the structured data, semi-structured data, unstructured data, and different kind of data. So based on the data types and complexity also, it's different. The business intelligence, which deals with the structured data, and here your data science, which deals with the diverse data, like the structured or semi-structured, whatever it may be. So it also need a further processing like data cleaning, feature engineering, and everything. So this is based on the data types and complexity. And next one, moving on to the next thing, it's based on tools, techniques, and skill set. For business intelligence, we may use this data visualization tool like Power BI, Tableau, and ClickView, Excel, SQL like tools. And for data science, for prediction and forecasting, we may go through Python or TensorFlow, Jupyter. So these are all the tools we can implement through the data science concept, for the data science concept. And techniques, based on techniques, it includes dashboard, querying, aggregation. But for prediction, for forecasting, for data science, which involves machine learning, statistical model, artificial intelligence, skills, user. So based on tools, techniques, and skill set also, it's different. Okay, so and this is based on tools and techniques. And impact and complementary. So business intelligence, which helps the business peoples to monitor and optimize the current operations. So like keep tracking and reporting the financial analysis, real-time things, dashboards, like visualization, it will give you. And through that visualization and insights, that day-to-day management can be done through the business intelligence. But while getting into the data science, by by visualizing, we can able to we can able to intake that patterns which are maintaining, and through the patterns we can able to focus the upcoming demands and everything, like sentimental analysis recommendation system that has been built through the data science. So so these are the things, and the data science and artificial intelligence, how it differs now. So these all things are interconnected. Yes, these all things are interconnected, but while getting into the in-depth concept, it's somewhat different. So then moving on to the next. So how the data science and artificial intelligence is differing? It's based on approaches, tools, and skills are proceeded over here. So there are 4 pillars of data analytics. So there are 4 analytics of data analytics we need to go through. The first one is descriptive analytics. Descriptive analytics is nothing. It's based on understanding what happened. Already we are having a lot of data. So it's based on historical data to identify the patterns, trends, and insight about our past completed events and performance. So it may leads to what happened in our historical data. So that has been included. That comes under descriptive analytics. And what are the techniques? These are the techniques like data aggregation, reporting, visualization. So these are all the techniques which involved in descriptive analytics. So next. So these are the limitation. There are certain limitation for the descriptive analytics. And moving on to the second one, it's diagnostic analytics. So it's based on the descriptive insights. It's based on the what happened. Based on what happened in descriptive analytics, the diagnostic analytics, which gives why it is happened. So why it has happened, what is the causes, and what is the reason, what are the attributes which tends to happening like that. So that are all the things which comes under the diagnostic analytics. So the techniques and example here, data mining, correlation, statistical test, investing. For example, sometime the sudden drop or sudden hike may happen on sales or stock market, something like that. So these all things has been handled under diagnostic analytics. By understanding why it is happened, we can able to prevent to not happen in future if it is it's a lower thing or something. So this comes under diagnostic analytics. And the third one is predictive analytics. First we saw that descriptive analytics, what happened, and second analytics, it is happened. The third one, what is going to be happen, what might happen. So the next one is predictive analytics. As we all people know, it's based on historical data, and by studying the historical data patterns, trends, and everything, that forecasting, we're going to forecasting the upcoming things going to be happen. So it focused from the past to future. So based on historical data, that the prediction can be done through some machine learning models and some tools. So here we can use regression models, classification algorithm, time series forecasting. So these are all comes under predictive analytics. So various machine learning algorithms are there for recognizing your patterns in historical data, and based on the pattern we can able to predict the upcoming things. So forecasting, which is a trending thing nowadays. So forecasting, which plays a vital role, prediction, which plays a vital role in each and every sector, like stock market prediction, gold price prediction. So it plays a vital role over here. And moving on to the fourth one, that's prescriptive analytics. So prescriptive, it's a vernacular for data analytics based on the predictive insights. Based on the predictive thing, we may go, what should be happen, and like that, what should we do. So it's like a prescription. So while we are getting into the medical field, if you're suffered from any kind of disease now, we will get some, if we are having any fever kind of things, we will get some prescriptive items to solve that to solve that health issue. Now, as like that, here the prescriptive analytics is here. If it is happen now, what we are going to do to rectify that? So that's a kind of prescriptive analytics here. So the techniques. So based on the predictive insights, based on the predicted insights, we can improve the accuracy and we can optimize the algorithm so to rectify the to improve the accuracy. So the techniques and examples like optimization algorithms, simulation models, so decision analysis, scenario planning. So these are all comes under the prescriptive analytics. So these are all the techniques we can implement in the prescriptive analytics to optimize the predictive accuracy and everything. So moving on to the next one. So these are all the four types of analytics we need to clear with it which type of analytics we are getting into. So if you are selecting any kind of research topics now, first you need to go through what kind of objective you are going to do, what kind of analytics we are getting into. Based on our requirement and based on our objective, we need to select the correct analytics over here. So four kind of things are there. That's descriptive. These are the four major types of analytics: descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So these are the main four things of four pillars of data analytics. So these are all the things I'm going to discuss. I've discussed you with you. So how the data science, artificial intelligence, business intelligence are interconnected, and the four pillars of data science. So thank you for the session.
Thank you, Dr. Surya. Next, technical session 3. I would like to welcome all the presenters for technical session 3. Presentation time for the presenters is 7 minutes, and the question and answers for session chairs is of 3 minutes. The session chairs are Ms. Sujata Balakrishnan, Dr. Chia Lee Siang, Dr. Mrinal Kantisen, Ms. Brixie B. Tupas, and Ms. Harshini Gadam. I would like to welcome Hardeep Singh to present the paper Climate Affecting Architectural Design. So Hardeep Singh, are you there? Let's wait for a few minutes and we'll be back. I would like to welcome Sangeeta Pandey to present the paper Quantitative Approaches to Smart Tolling, a queuing theory-based evaluation of fast-tag operations.
Thank you, sir. Good morning. I'll just share the screen. So am I visible?
Yes, ma'am.
Can you see my screen, sir?
Yes, ma'am. We are able to see your screen. Please share your PPT, ma'am.
So from share, I have to share screen. It's not showing actually. From share, I have to say share the screen.
Close this Zoom meeting. Minimize the screen, ma'am.
No, in Zoom meeting, in share, I have to click, right?
Yes.
But when I'm sharing, it's not showing my desktop work. Can you guide me, please? It's not showing here. Meeting. So from share, I have to share the screen, but it is not showing, sir. What should I do?
1 minute, ma'am.
Please open your PPT first in the desktop. Okay.
Okay, ma'am. Okay.
Minimize this. Please open your PPT first.
Okay, ma'am. Okay. अभी यही होंगी. Wait. Are you able to see, ma'am, my screen? PPT?
Yes. Okay, you can present now.
Yeah, ma'am. Thank you. So very good morning to everyone, all my respectives and all my colleagues. Myself, Sangeeta Pandey. I am a research scholar from Kalinga University, Raipur, from Mathematics Department. Today, I'm going to do my presentation on quantitative approach to smart tolling, a queuing theory-based evaluation of fast-tag operation. These are the contents I have prepared for my paper, and descriptions is here. So, introduction, optimizing toll plaza efficiency in India through queuing theory. Toll plaza in India face increasing congestion due to growing vehicles numbers. Delay lead to fuel wastage, pollution, and inefficiencies. FASTag is a contactless RFID-based toll collection system introduced to reduce congestion. This presentation outlines a comprehensive study on the impact of FASTag implementation on toll plaza operation efficiency in India, utilizing queuing theory for quantitative evaluation. I will explore how smart tolling system can significantly enhance traffic flow and resource utilization in developing regions. As we know that before 2019, traditional toll plaza was working in India. Traditional toll plaza. Manual toll collection often leads to significant traffic congestion, increased travel times, and higher fuel consumptions, posing a major challenges to urban and intercity transportation networks. In February 2019, the FASTag was done mandatory. From that, FASTag is an India electric toll collection system aims to revolutionize toll operations by enabling cashless payments and reducing vehicle waiting times, thereby improving overall traffic fluidity. Research imperatives, a quantitative Here, research imperative is a quantitative analysis using queuing theory is necessary to access the actual benefits of FASTag and provide data-driven recommendation for further optimization. Objective of my research work is here to analyze the toll booth performance pre and post FASTag implementations, model performances, connect queuing model with real-world tolling scenarios, to develop queuing model either MM1 or MMC to stimulate tollgate performance at selected Chhattisgarh sites after FASTag. Evaluate impacts will be to quantitatively evaluate the impact of FASTag on key performance indicators, average waiting time, queue length, and service uses. Optimized resources will be to offer data-backed suggestions for optimal resources allocations and traffic control strategies at toll plazas. During my literature review, I found the research gap, limited application of queuing theory. There are a lot of research has done on FASTag, but based on the mathematical, quantitatively, research is not too much available. Few Indian studies apply MMC models like MM4 to analyze real-world toll plaza performance. Another research gap I found was lack of real-time traffic analysis. Most research uses average daily traffic data, ignoring hourly variations and peak of trends. Minimal focus on dynamic operations. Current studies rarely suggest dynamic toll booths allocation or adaptive toll pricing based on live traffic. Insufficient localized studies. There are too much studies has done on FASTag all over the India, but in small regions like especially on Chhattisgarh state, there's a limited research. So I have took a Durg bypass toll plaza, which is located on NH33 in Chhattisgarh. I have chosen that for my presentation. Novelty of this study. The study introduced a practical application of MM4 queuing model to a real-world traffic congestion scenario at Durg Bypass Toll Plaza NH33, offering a quantitative approach to understanding and optimizing toll plaza operations. Unlike traditional observations method, this research leverages hourly vehicle data and queuing theory metrics to accurately assess system insufficiencies. By combining predictive models with operational insight, this research provides a scalable framework that can be replicated across similar highways toll plaza point nationwide. I have chosen a nation research methodology, quantitative and analytical approach with descriptive and applied case studies, with focusing on congestion analysis at Durg Bypass Toll Plaza on NH33. Data has been collection, primary data from toll plaza records for periods of 7 days from Saturday, Sunday to Saturday, hourly cycles, hourly intervals. And my metric is to collect the number of data going or passing through vehicles per hour. Study location is NH33 Durg Bypass Toll Plaza at Dhamda Naka, Chhattisgarh. Purpose of data collection is to observe arrival pattern, analyze peak and off-peak traffic flow, provide input for queuing model analysis. For doing the research work, the tool has used queuing theory MM4 model, Excel for calculation on all the graphical representation, MS Excel software has been used, and mathematical formulas for doing all calculation, traffic intensity, queue length, waiting time, probability of ideal time has been used. Analysis method is descriptive analysis method for hourly and daily patterns. Queuing analysis using MM4 model. Comparative evaluation is weekdays versus weekend congestion has been done for the comparison. Interruptive analysis is used to identify congestion trends, system insufficiencies, and purpose adaptive solutions. This is the data I have collected through for doing my all research work between 16 to 22 February 2025, Sunday to Saturday. 1 week data per hour, number of vehicles are going through the toll plaza. This analysis or calculation data has been collected. Now, as I have chosen the queuing model to do the analysis at toll plaza, so a little short description of queuing model. Queuing theory is a part of mathematical, and it helps us to analyze analyze how much number of calculation or how much number of things can be done in a limited source of time. So here queuing theory offers a mathematical approach for analyzing traffic jams and improving toll gate service system. The goal is to analyze traffic congestion at the bypass toll plaza using MM4 queuing model, where M represents a poison arrival process, another M represents an exponential service time, C represents number of servers. So here we have 4 number of toll booths. So C is equals to 4. The model of discipline is first come, first serve service. For the MM4 model, we will assume that processing rate per lane is similar to the average flow during the peak hours. Here, average arrival rate has represented by lambda and service rate is represented by mu, where we are assuming that it is mu is equals to 300 vehicles per hour going through the are getting service from the toll plaza. After getting the calculation with the help of Excel software, I have calculated all the traffic intensity, number of vehicles per hour, service utilization, the queue length, everyday queue length, waiting time, vehicle in system, time in the system, probability of vehicles. Or from Sunday to Saturday, this calculation has been represented here. After doing all the calculation, as we know that graphical interpretation helps to analyze the data, so the results. So these are the graphical interpretation representing here. This is the line chart showing the traffic flow at the toll plaza by hour for each day of the week. This visualization helps identify peak traffic periods for compare daily variations. As we can find that most congestion is on Fridays or Saturdays. This is another graphical interpretation, and the comparison has been done between waiting time in the queue and traffic intensity, queue length versus days of the week, traffic intensity versus days of the week, and traffic distribution of the day. These all graphic interpretation are helping me to do the calculation and reach to the results. This is another graphic interpretation, waiting time in the system versus days of the week. This comparison has been done. Then traffic intensity versus waiting time in the queue. Then waiting time in the system versus days of the week, and waiting time in the queues versus waiting time in the system. This comparison is helping us that how much waiting time or is on days or waiting time in the week to do the analysis. After doing all these calculations, the analysis has been found that traffic intensity is ranging between 0.7 on Wednesday to 0.79 on Saturday, which indicates higher server utilization or the toll plaza services, especially during the weekends. The system and also as rho, traffic intensity is less than 1, which shows that traffic is efficient but approaching capacity limits. Queue length is ranging between 5.11 vehicles on Wednesday to 6.12 vehicles on Saturday, which shows that longer queues during weekends signal increased traffic volumes. Waiting time in queue is ranging between 20. So every vehicle in weekends, the maximum waiting time in the queue for the vehicle is 21.2 seconds on Wednesday, and maximum is 25.2 seconds on Saturdays, which indicates that slight rise in waiting time during peak traffic periods. Probability of number of vehicles in the system. It shows that lowest on the Saturday, the probability of number of vehicles in the system, it is indicating that system is almost constantly active on weekends. Saturdays are the most congested days, suggesting needs for dynamic traffic handling strategies. discussion and recommendation. From the research work done on the basis of MM4 queuing model, it is I have come to the after doing all discussions that effective overall performance, Duke Toll Plaza generally operates efficiently. Traffic intensity is less than 1, which indicates manageable system loads. The peak traffic period is mostly on Saturdays. High queue length and wait time observed on Saturdays. The recommendation for that is add toll booths or implement dynamic pricing to ease the congestions. Underutilizations of peak days, weekends and weekdays or Saturdays. The comparison found that system operates below capacity, leading to the ideal resources. The recommendation is here to use real-time traffic monitoring dynamically adjust number of active booths. And after doing all the research work in this topic, I came to the conclusion that the study shows how MM4 queuing model can be used to analyze and enhance toll plaza performance. We can find inefficiencies in the present system and offer innovative ways to reduce congestions by measuring traffic intensity, waiting time, and queue lengths. The result shows that in order to improve the toll plaza capacity to control traffic and minimize delays, particularly during peak hours, adaptive solutions like dynamic tolling and flexible server allocations are required. And reach to the conclusion and policy implementation validate effectiveness of this research work is the study quantitatively validates the significant positive impact on FASTag on toll plaza efficiency, demonstrating its potential as a transformative intelligent transportation system. Actionable recommendations are provide practical guidance for transportation planner and policymakers on optimizing lane configuration, particularly in emphasizing the benefits of multi-server setups. Future-proofing infrastructures and highlights the importance of integrating operation research and mathematical modelings for developing resilient and efficient tolling system in rapidly developing regions. These are the differences I have gone through during my research works. Thank you so much for providing me this opportunity to be a part of this conference and get the opportunities. Thank you so much.
Thank you, ma'am. Session chairs, you can ask questions.
Okay. Good morning, ma'am. So,
good morning, sir.
Thank you for sharing our work. I have one question. Question is like, why you have chosen queuing theory? What is the significance of queuing theory to evaluate FASTag tool operation?
So queuing theory actually helped for my research work. I took the FASTag. I was very keen that how it has impact on the toll bags, especially on traffic congestion, pollution, and all. So as I am my field is especially mathematics. So through the queuing theory is the part of the mathematics which help us to find out, which can help me to find out the FASTag, especially how much is the traffic and how much arrival rate is there, how much service rate is, what is the before FASTag and after FASTag, what is the difference of time, and especially for congestion, the people, the fuel abolition, and also I'm working for this pollution rate is controlled due to the after implementation of FASTag. So with the help of queuing theory, I can get all the formulas which can help me to calculate all these and analysis that how a FASTag has improved the toll plaza efficiencies.
Okay. So is there any other model you can use for this study besides theory?
So mostly as this for my research work, especially the FASTag, my points are that evaluate revenue collection effect and the population, the congestion, and worker efficiency. These are my criteria to do the research work on that. So when I gone through in mathematics, especially in operation research, so only queuing theory is the portion where I can do all the calculations.
It means
rest of the topics I can do some calculation, but not all the things.
Okay, it means based on your data collection, queuing theory is the best fitted for your research, I think.
Yes, sir.
Okay, thank you, thank you. That's all
Thank
from
you, sir. Thank you so much.
Sangeeta ma'am, you please stop your screen sharing.
Yes. Is it okay, sir?
Yeah, okay, ma'am. Next, I would like to welcome Kritika to present the paper Advancement and Challenges in Video Forgery Detection, a systematic review of techniques for deep fake and manipulated video detection. Kritika to present the paper.
Good morning, everyone. Am I audible?
Yeah, audible. Sangeeta madam, please stop screen sharing. May I request Sangeeta ma'am to please stop screen sharing? Thank you. Kritika ma'am, you can start.
Good morning, sir. Am I audible?
Yes, ma'am, audible.
Okay. Good morning, everyone. My name is Kritika, and I'm
Please turn
doing
on
my...
your video, ma'am. Kritika ma'am, please turn on your video.
Is it okay, sir?
Please turn on your video.
It's on, sir.
PPT is where we are able to see, ma'am, but your video, your face.
Okay. Am I visible, sir?
No, ma'am.
No?
Only your background is visible.
Now?
No, ma'am. Only your background is visible. We are not seeing your face.
So video is on from my side. I don't know why I'm not visible to you.
Okay, share your PPT and present, ma'am.
Okay.
It's getting back.
Okay. Is it visible?
Yes, ma'am.
Okay. My name is Kritika, and I'm doing my research in Punjab University under the guidance of Professor Satish Kumar, and my topic is systematic review of video forgery detection. See, as technology is enhancing by leaps and bounds, information nowadays represented through video rather than textually. Earlier, forgery takes place with textual information, but nowadays video forgery is common. Video forgery detection is significant due to the rising use of manipulated videos for deceptive, malicious, or criminal purposes. With advancements in technology such as deep learning, AI, and powerful video editing tools, creating fake videos has become easier and more realistic, posing serious threat. So, the need for video forgery detection arises from widespread societal implications, including misinformation, legal system, national security, privacy, and media integrity. As forgery tools become more sophisticated, the ability to detect tampered videos become critical to protecting the truth, preventing harm, and ensuring trust in digital content. So this topic raised some research question that we have addressed in front of us. Research question one is techniques for dynamic and motion heavy content videos is required. Second question, effectiveness on low resolution videos is required. Third question, which data set and what evaluation metrics have to be used. And the last one is we have to handle the unaddressed challenges and future need have to be focused. In my review, I have searched IEEE, Springer, and Elsevier 2015 to 24 papers by using the keywords CNN, deep learning, video forensic, and AI. And I have used Prisma and filtered out the 35 peer reviews paper by using inclusion and exclusion criteria to get better quality of papers. So let's focus on the forgery types in front of us. We have intra-frame forgery, inter-frame forgery, and frequency domain forgery. As we have discussed about intra-frame forgery detects region or object manipulation within a single frame. And in inter-frame forgery, insertion, deletion, duplication among frames was detected. In frequency domain forgery, we will use spectral clues, use DCT, DW, F50 like algorithms to detect the forgery in the algorithms. And in these papers, in these forgery types, I have studied some papers that using different techniques. Here I have a literature review according to the forgery detection, in which I have studied some paper from 2015 to 24 and see the techniques used by different authors and evaluate the metrics according to that techniques and get the advantages of that technique. This is the review of intra-frame forgery, where we have used techniques like motion resolution, prediction residual, dense field randomized patchmaking, correlation metrics, shift movements, optical flow, YOLO, phase-based motion, DCNN motion like algorithms to detect the forgery in the video. And in interframe forgery, we have used brightness variance descriptor, PU partition histograms, LDA, KNN, mean region-based correlation, exception CNN like algorithms, and hybrid 2D, 3D CNN algorithms to detect the forgery in the video frame. And in frequency domain based forgery detection, we have used techniques based on the frequency like FFT, DWT, discrete wavelet transformations, EFMs, DCT, PCT like techniques to detect the forgery and get the metrics according to that. The core techniques that I have explored according to the review is to detect and analyze video forgeries. Some core techniques explored, that is spatiotemporal analysis, motion models, and background subtractions. These methods focus on identifying inconsistencies in spatial and temporal domain. In spatiotemporal analysis, we will detect motions and light inconsistencies in spatial as well as temporal frame. In motion models, we will track the object and trajectories or anomalies within the frame to detect the motion objects. In background subtraction, we will isolate foreground from the background to detect the static or dynamic objects in the video. So we will use, in future, we can use hybrid and multimodal approaches to get the higher accuracy in the video detection. In future, research in forgery detection focus on improving robustness in dynamic backgrounds and motion-heavy scenes by using advanced spatiotemporal and motion model techniques. This will help better distinguish real object movement from environment changes and detect subtle inconsistencies in high motion models. So, in future, dynamic lighting, and crowds under robustness is required. Some low bit rate and mobile footage have to be handled, and in real time deployment on edge devices is required, and by using AI and forensic techniques we can easily find the forgery in the videos. At the end, I'm concluding this topic. Video forgery detection remains a complex challenge, especially with advanced techniques like deepfakes, dynamic backgrounds, and high motion scenes. Hybrid approaches combining spatiotemporal analysis, motion models, and background subtraction along with AI and machine learning show strong potential for more accurate and robust detection. These are the references that I have used to conduct the review of my paper. And at last, thank you for giving me chance to present myself in this environment.
Okay. Thank you for sharing your work. This is a review paper, I think.
Yes, sir.
You have not collected any data from any domain or something.
Sir, I have conducted a review.
Okay. So, like, you have compared with different type of algorithm or what?
Yes.
Okay, sir. Can you tell me like which algorithm fitted best for your research and what accuracy?
Sir, actually, after review, I thought that I will hybridize CNN
Okay.
with some frequency domain algorithm to get better accuracy, as frequency domain algorithms are better in accuracy.
Means have you compared your CNN model with other model? Means how you can conclude that like CNN will get more reliable? So have you compared or have you done any analysis for that?
Yes, sir, I'm doing work on this topic.
Okay, okay. This is your future work. I think.
Yes, sir.
Okay, okay. Thank you. Thank you. That's
Okay,
all.
sir.
Kritika, ma'am, you can close your screen. Stop sharing your screen, sir. Thank you. Next, I would like to welcome Samriddhi to present the paper Utilizing IoT for Intelligent Urban Areas, Integration Obstacles and New Technologies for Sustainable Living.
Good morning, everyone. So am I audible?
Yes, ma'am.
Good morning to all the dignitaries and the panelists. I'm Anuradha Saini, and I'm going to present this paper. I'm the co-author of this paper, and the title for my paper is Utilizing IoT for Intelligent Urban Areas. That is integration, obstacles, and new technologies for sustainable living. It is more of a review paper, not a research paper as such. So I'm going to explain all the parameters which can be used and are has been in use for this IoT present. So the background for my this review paper is how and all these parameters are integrated in the IoTs and from where till now we are moving. So in 1960s, there were just communication between the persons and they just know how to this technology can be implemented. They just communicate verbally and share their data. And in 1990s, when the technology enhances and the networks comes in between the host and the web, where the web actually started working. And after that, the mobile comes in, we came with the internet, and with the internet, we had the PCs and we used our PCs for communicating, which makes it a bit more easier to send and for the communication purpose. And next is the when we got the mobiles in our hand, so it became the mobility comes in the picture, where it was static earlier, but now after the mobile comes in the picture around in 2000, after the 2005 or 10, where the internet comes with the mobile and we could send all the communication through from any mobile state. So no, it is not static now anymore. And after that, the PCs, people, mobile, and all the technologies came in the picture into 2020, and where the IoT has started. So this is the main background from where we have started from 1960 till 2020. This is the basic transition between the technology and IoT comes in the picture. So these are the main technologies that are being used for so many smart cities. Like Zigbee can be used and is many people are using for home automation, and actuator technology is has been used for smart lighting, air conditioning in home, and which is very much useful, and people are using in their very day-to-day life. And at homes also it has been implemented now. Earlier it was in a research centers or in some institutes only they were using the smart lights and air conditioners, but now all the people and even in the all uh, general equipments, the IoT has been implemented, and actuators, by using the actuator technology, all smart lighting or air condition has been modified. With the technology MQTT, the transport system has been automated and IoT has been implemented so that the tracking can be done, so that the how the particular transport system can be connected with the internet, and we can get all the updated things, and the information or communication can be done with the transport system. Next technology is ad hoc technology, which we are using for the smart health, like the watch, smart watch we wear, and where we have an app of smart health. So here the ad hoc technology has been implemented. And the last one is the GPS technology, which has been used for water waste management systems, smart home systems, smart parking. So it is specific to the location where the person is, and it has been implemented for tracking the exact location or for what the route can be acquired. And each and every person right now is using the GPS system in their mobiles, and it is inbuilt in the system, and we can implement it and use it in IoT. So this is the basic model where we work for the smart cities. So this is the architectural layer model for fog. So this at the we are the users, and we call fog users. We use the data which is available on fog, not on the cloud directly. So cloud gives the data to the fog, and fog we data from the fog. So that's why this system is a bit faster and reliable. Fog connects with the cloud, and we people connects with the fog through our mobiles or through our PCs. So at the middle layer, that is fog layer, where we work and where the IoT has been implemented. The cloud layer is just for the data. All the data has been stored on the cloud, and at the fog layer, all the technologies which I have told you in the last slide, all these technologies has been implemented at the fog layer, and at the edge layer, we just access it through our apps and the different equipments for implementing all the technologies. So these are the basic challenges that are related to the smart cities. The first one is security. If we are implementing through the fog, it can be available data. The data can be available open to public. So we must have some authentication, some security tools must be implemented at this level. Second thing, power supply. That is the main issue. If we get some backup also, but it is again the limited. We can implement it for a limited time period. So power supply is always must be there for implementing smart cities through the IoTs. And next is discovery is very limited. We are working on it. Each and every researcher, those who are these topics are working it on it as it is a new technology, and there is no as such background or a detailed background available. So it has limited discovery. Next is software complexity, as it has a multiple technologies for multiple equipments, and we have multiple technology for different types of data. So these technologies have a very software complexity, limited softwares available to implement it, but it is a very vast thing. So now they are working on implementing all the IoTs through machine learning to data analytics. It is very much required for deep learning so that the machine can learn itself and it can implement all these things, and through can accommodate, and the time can be reduced, their flexibility can be enhanced. Wireless communication. So internet should be available at every part. It is now available, but in each and every equipment, you need the wireless equipment so that they can be connected from anywhere and free with any device. Fault tolerance is still low. We are all are working. It can be increased. Fault tolerance can be minimized, and all the equipments can be worked on by covering all these challenges and can work properly. Autonomy and control. It is totally related to the security and correlated with it, as we can control it from anywhere, and those who are authenticated can only access it. But still, as it is an electronic devices or electronic equipments, they still have some loopholes. Like you can see the some theft cases of cars and some automobiles, just by pressing some keys on their board, and they can unlock the car and anyone can start it and drive it. So this is the a bit of loophole on which everyone has to work, and this is the main challenge for everyone. And the next is the privacy. Most of the work has been done on it, but still it is a challenge. We have to work on the fog layer, not on the cloud directly, where the authenticity has been implemented. But at fog layer, the data can be only because of that fog layer, that control can any other person can get without authenticity. And these are the main conceptual framework for smart cities. Like data processing level is done on the smart health, smart waste management, smart traffic, smart home, smart grid, like biomass fuel, solar panels, smart buildings. And then the data transfer level hai, that is on fog layer, the middle that is IPNet. And Then the data monitoring and actuation level, where it has been implemented with the people on their phones, on their equipments, on their watches, and IoTs. These are the IoTs technologies, actuators, LEDs, and all the things. Then this on the streets through cameras, which is the police and the is using the smart cameras for making challans, for cutting challans of the persons, those who are riding fast or on the or crossing the red lights. Next, the vehicles. In the vehicles, most of the vehicles are using IoT now. Car, trains, buses, cycles, but this technology is almost endless, and with each and every year, any new feature is adding up in it. And the home, now I have told you, like smart automated lights, air conditions, smart ACs, smart TVs, smart fridges, all this has been implemented now. So this is the conceptual framework, and the main thing is these are the parameters which each and every person has to take care while doing the research, and has to uh, enhance it, and at every point it has some loophole. There are some loopholes in every parameter, and we can, by doing more research, by implementing it with machine learning, deep learning, with the emphasis, so it can be improved. So these are the future scopes also where the researcher can work upon. Thank you everyone for giving me this opportunity and for patiently. Thank you, sir.
Hello, ma'am. So congratulations for your work. It's a nice work. I have one question. Can you suggest some real example of how IoT can help make cities like smarter or more sustainable?
So basic, and the first example is the cameras that has been implemented on traffic lights,
Okay.
where now the traffic challans can be done easily, but more on, not only for challans, these cameras can be implemented for handling the traffic, where the traffic is more, so it can be send the check signals on the last lights or on so that the traffic can be diverted towards another path. So this is the another research area where we can work upon,
Okay.
and it can be displayed on the road that there is a congestion, there is some accident, there is anything happening in a next slide. So this is the basic example. Second is we are using so many appliances at home, like IoT is it has been implemented in smart fridge and all.
Yes, yes. Okay.
And
Ma'am, one more question. Like,
yes, sir.
what upcoming IoT technology do you think will have the biggest impact on future smart cities?
Uh, the main thing is on authenticity and control that I was talking about. Like I gave the example, we have a car with all the new sensors and all, and it is very automated and IoT implemented. But still, a person came with a box in his hand, and just by clicking and just by matching the frequency, they unlock and they can just stole it within a second, which was much more
Yes,
easier now as compared to the manual one. So at
yes,
that point, we have to work upon. And this
yes,
IoT now, whenever a person will try to unlock it, there can be some password, there can be some
yes,
message that can be
yes,
sent, there can be some alarm.
yes, yes.
So this can be done for it, and
Okay.
it can be implemented on every device or every
Yeah.
equipment.
Yes. Okay. Thank you, ma'am. Thank you. That's
Thank you.
all.
Thank you.
Next, I would like to welcome Hardeep Singh to present the paper, Climate Affecting architectural design. So Hardeep Singh, you can present your paper.
Sir, I am audible.
You're audible.
Good morning, sir. My name is Hardeep Singh. I am student of BTech Civil Engineering. My topic name is Climate Affecting Architectural Design. The goal is to conduct a practice investigation into the interaction between climate and architecture during the design phase and identify the build form
So sorry to
expression
disturb
of
you, Mr. Hardeep
architecture.
Singh. Can you please share your PPT?
Yes, sir.
Can you please share your PPT?
So there is a network issue.
Okay.
So that's why I will not present the PPT.
Yeah, okay. Go ahead, please.
The goal is to conduct a practice investigation into the interaction between climate and architecture during the design phase and identify the built forms expression of architecture in terms of emotional experience, spatial comfort, materiality, and energy efficiency. Building design is influenced by the program context, climate, and concise circumstances. However, the mentioned ones take precedence over other criteria. A successful design must correctly coordinate them as they are illustrated. Buildings are more impacted by climate since it affects how comfortable is food. Building procedures in architecture have always been based on context and period. The stage on concept and construction are starting point of the design process. The role of architectural design could be used to track climate variable. Recurrent climate change is the factor that we like to experience throughout time due to both natural and artificial factors in case of the climate. Architecture's expression varies depending on the setting, materials, construction process, and technology, all of which vary over time. In all instances, the tangible and intangibles coexisted and the link between climate and architecture change over time. From the perspective of climate factors like hot and cold seasons, light, winds, humidity, and precipitation, the distance to attribute might be degraded. When architect elements respond to environment factors including heat, cold, light, wind, humidity, and precipitation, they reveal themselves to the outside world. Every scene climate characteristics is taken into the consideration while creating an architectural marvel. The tangible quantity is integrated with architectural features throughout the design phase of architecture, causing the environment's integrated quantities to change the weather and climate. The demonstrates that the concept stage deals the integrable while the construction process focuses on tangibles like human comfort, the structure's durability, and even resistance to the negative impact of the climate. How the climate affects the regarding analyzes historical climate condition in order to design buildings and predict future weather conditions in order to alter civil operations. When examining the historical climate, the result of the climate response must be considered. Concentrating simply on one or two climatic factors is by no means sufficient because all aspects are important even though they have varying weights. Understand the process of how well article has been connect with the setting may help you better comprehend the potential effects of climate variable on architecture. Thank you, sir.
Thank you for presenting your work. Okay. In your work, have you find any software or tool for finding out the climate impact on infrastructure or architecture design? Is there any tool or software available?
Yes, sir.
What is the name of the software?
हाँ जी सर.
What is the name? नाम क्या है उस सॉफ्टवेयर का?
सर सर स्टैट प्रो हो गया सर.
No, State Pro I don't think is go for climate. It's for design only. Okay, ठीक है.
Okay, sir.
Okay,
Thank you, sir.
thank you. Thank you.
Next, I would like to welcome Raman Kumar to present the paper on topic different aspects of mud house. Mr. Raman Kumar.
Hello, sir. Can I audible?
Yes, you are audible.
My name
Please
is
present
Dilip
your
Singh. I am the
PPT.
co-author of. I am a student of BTech
Mr.
Civil
Raman Kumar,
Engineering.
sir, I request you to please present your PPT.
Yes,
Please
sir.
present your PPT.
Hello.
Sir Raman Kumar.
Raman Kumar, please start your work.
My topic is different aspects of mud house. While a home is formed of hearts, a house is constructed of buildings blocks. Everyone is working really hard to make ends meet in today's hectic world in order to have a sufficient and sustainable shelter for a healthy existence. Cement and concrete have dominated the construction business for so long now that the average person has stopped considering any natural building materials as an alternative. This article is used to know about the details of the mud construction and how useful it is to the person, environment, and people in the present generational are spending more money for construction and making environment polluted. Also, this article may help you to overcome this problem. Scope and the primary goal is to get knowledge of the specific of mud building and how those dwelling are used now. Knowing the benefits of mud building and the purpose of living in such houses another goal. Mud is a brand new non-polluted substance with the no embodied energy remaining connected to nature. Mud construction may be recycled without harming the environment. Mud structure special capacity to breath allows them to guarantee improved health and infuse their occupants with pleasant energy. The local answer demonstrates that mud is a good material. Temperature control. Global warming can be mitigated by using mud structures. They are considering the cooling effect within the mud homes are currently in higher demand building when compared to brick walls plastered with cement. Mud structure achieve a structural economy of about 20 to 25%. The potential for using mud as a sustainable building material is unquestionable and enormous, but only if it is promoted and used with the principle of sustainable development given top priority. Thank you, sir.
Thank you, Ramanji, for presenting your work. So I think your work is review on mud structure.
Yes, sir.
it is a review on mud structure. You did in review on mud structure, I think. So I
Yes.
have one question. Question is, what is the environment advantage of mud structure as compared to concrete structure?
Sorry, sir. Repeat करें.
What is the advantage of mud structure as compared to concrete structure? Advantage क्या है mud structure का? क्या फायदा होता है?
It helps to make house cold.
Okay. Means temperature will be drop down. Okay. Thank you.
Thank you, sir. Sorry, सही है.
सही नहीं है सर हंसी है तो सीगा
Next, I would like to welcome Sumanpreet Kaur to present the paper Effects on Tensile Structures with Evolution of Materials.
Good morning, sir.
Good morning. Please
My
present it.
My name is Sumanpreet Kaur. I am student of BTech Civil Engineering, Baba Farid College of Engineering and Technology. My topic is Effects on Tensile Structures with Evolution of Materials. In this paper, various forms and uses of tensile structures are reviewed, together with important materials for tensile structures, as well as its historical importance with relation to the recently built samples of such structures. The aim of is to find how form of tensile structures involved with the evolution of materials. The construction design that developed over time using more advanced material and construction methods to produce larger and more diverse structures. Form of tensile structures has changed over time from simple circular forms to complex doubly curvature. This change in form was possible only with the evolution of materials of tensile structures. So, with more advanced technologies and with the evolution of materials, the form and use of tensile structures has changed over time. Tension fabric is not relatively a new building material, despite its more extensively used over the past decade or so. In architectural applications, in early ages of nomads, small span tents were made with same techniques, but the material used were animal leather, timber, etc. Later, during Romans era, it was used as covering for large spans such as sports, arena, such as colosseum, and the material were timber, fabric, etc. In 19th, after the Industrial Revolution and with the production of steel, use of these structures gradually increased in the field of architecture. These were now used as roofing for large span stadiums and exhibition spaces made up of steel elements and fabrics such as polyethylene. This was possible due to advancement of materials, so it is definite that the form and application of tensile structures has evolved with the invention of new materials. The advantage of tension fabric cannot be disputed, especially over large areas. It is an incredibly lightweight, material saving, and energy conserving solution for roofing systems. In short, it is an excellent option for architects and engineers for designing sustainable structures. Thank you, sir.
Okay, congratulations for representing your work. So you did one review on tensile structure with year-wise, like evaluation of tensile structure. So my question is, do you think that nowadays what is the advantage of new that tensile structure as compared to traditional one? There should be some advantage of that new tensile structure as you have reviewed. Can you tell me one advantage of new tensile structure as compared to the traditional one?
It can be provide more tensile strength.
Okay, it can provide more strength. Okay, thank you. Thank you.
Next, I would like to welcome Prasanpreet Singh to present the paper Astronomical Observatory Instruments, a Design Element. Mr. Prasanpreet Singh.
First of all, good morning, everyone. My name is Prasanpreet Singh. I'm from Bathinda. I'm studying in a BTech Civil Engineering and I work at College of Engineering and Technology. So now, the name of my topic name is Astronomical Observatory Instrument, a Design Element. The cosmic architecture has been a great tool since long ago, when Greeks started using it for calculating the times and date, using some astronomical instrument like sundial. A sundial is a device that helps in getting the local times of a particular place using the projections of suns and shadow formed by the gnomon ST. After the development of trigonometry, more complex and precise sundials comes into existence, as the earliest were based upon the geometry. The use of sundials nowadays is preferred by top-level scientists over the Indian standard time for exact calculation, as it provides us with local times, and the local times in gnomon is aligned with the geographical north-south axis. In these papers, it has been shown how the devices can be used as a design element in the residential and the public places, and in particular, talk about the Sandal Bridge. A case study about it has been done. Most of these type of sandals can be derived or acquired by the projections of equilateral sandal itself. The instrument can be used for both educational purpose and as a design element in the residential houses, public places, and landscape elements, or roundabout on the road bridges. From the case studies discussed above, the concept of the sandals, we can conclude that sandal can be used as a design element in the practical field. Horizontal sandal derived from the projections of equilateral sandals can be used on the grounds and can be amalgamated with the architectural elements to come up with a new and innovative designs. At the end, it can be concluded that it is due to the invention of trigonometry. These instruments achieve their full efficiency and making these astronomical instruments worth studying. The instruments like sundials give more precise value than the modern magnetic tools, as it seems in the case studies. Sundials and other related tools can be used as an excellent landscaping element.
Okay, thank you for sharing your knowledge. So I have one question. Question is, what are the key design factor to consider when you plan instrument for an astronomical observatory? What are the factor, as you have mentioned that you did some case study? So what are the key factor you have considered?
Sir, new model designs and the thermal accuracy. These are the main characters.
Okay, thank you.
Next, I would like to welcome Ramanpreet Kaur to present the paper Sustainable Building Construction with Conventional Residential Building Comparative Study. So, Ramanpreet Kaur. Priya Kaur or Pooja Kaur, you can present the paper On behalf of Ramanpreet Kaur, Ramanpreet Kaur, are you there?
Yeah. My name is Pooja Kaur. I am I'm student of Baba Preet Group of Institution. My topic is there is some technical issues. Sustainable. My topic is sustainable building constructions with the construction conventional residential building comparative study. In this topic, we are researching examine features of residential conventional constructions that are sustainable. Due to this, there is a large need for low-cost urban housing developments constructed with materials that are readily available in the area. Sustainable homes can lessen the negative effect of constructions on the environment. It safeguards the natural resources, the ecosystem, and the climate. As a result, the project takes into account certain materials that might be meeting in the minimum needs. In general, the use of concrete is not a unstable one because it requires a lot of energy for the phase of the construction for the phase of the uses of concrete is not sustainable one because it requires a lot of energy the phase of the construction as well as for the production and manufacturing of cement and its component. However, the importance of building using sustainable material is the crucial from both a technical and environmental perspective. The project's primary goal is to gather life cycle information and conduct a cost analysis to determine whether a sustainable residential constructions made primarily and of mud is feasible compared to more conventional residential structures. Mud building, sustainable materials, material testing, and affordable construction are some related terms. Thank you.
Thank you, Poojaji, for sharing your work. This topic is very important nowadays. So, I have one question. Question is, what is the main difference between sustainable building and conventional residence building in terms of, say, material or design?
The material will be low cost.
Okay, thank you.
I would like to request to welcome Balakanna to present the paper on digital marketing dynamics, analyzing the role of social media in shaping consumer preferences for health and wellness products. Mr. Balakanna to present the paper. Are you there? Mr. Balakanna, are you there? I request all the participants to turn on the video to take a picture. I request all the participants to turn on the camera to take a picture. I request all the participants to please turn on the camera to take a picture. Thank you. Please wait for 5 minutes. We'll announce the results. Congratulations to all the participants. I'm going to announce the best paper goes to the paper title Exploring Zero Trust Adoption in SQL Server, a study on least access privileges and behavioral analytics. Authors Maynard Capel and Dr. Daniel Dessig. Next is best paper presentation. Goes to the paper title Quadratic Modeling in Informatics Education, Application Methods and Pedagogical Approaches. Authors Dr. Chetna Sharma. Next, best paper innovative research goes to Rizwana Parveen, a novel family of legend-based Apple type polynomials and numbers. You will get the certificates by tomorrow. Vote of thanks. On behalf of CELDA, I extend my heartfelt gratitude to all the delegates, students, researchers, and participants who contributed to the success of ICAMET conference. The conference centered on the theme Driving Innovation and Sustainable Solutions, Interdisciplinary Approaches in Applied Science, Business, and Technology was a resounding success, enriched by the insightful address of the eminent keynote speakers from esteemed universities. We sincerely thank all the speakers, session chairs, delegates, and participants for their invaluable support and active engagement. Special appreciation goes to the organizing committee members and editorial board for their unwavering dedication and contributions which made the success of conference possible. Special thanks to the organizing committee members, conference secretary, Dr. Nayara Radwan, associate professor, Egypt, scientific committee members, Mr. Gokul Ram Krishnan, Delaware, United States, Dr. Lakshmi Narayan Soni, assistant professor, AKS University, India, Dr. Siddhapaji Amor, associate professor, Bangalore, India, Dr. Deepa Bandana, research, Meerut, UP, Mrs. Abha, HOD and assistant professor, Karar, Punjab, Mrs. Harbinder Kaur, assistant professor, Department of Mathematics, Punjab, India, Mrs. Ishpreet Kaur, assistant professor, Sahib, Punjab, India. Review committee, Dr. Abdul Mateen Ahmed, associate professor and head of department, India. Dr. Jonal J. Abalajan, Quality Management, Philippines. Dr. Nihar Malali, Dallas, Texas, US. Dr. Chetana, assistant professor, Patiala, Punjab, India. Dr. Kiran Panchal, director, Haryana, Punjab. Dr. Happy Kumar, assistant professor, Punjab, India. Dr. Ankit Jaga, assistant professor, Punjab, India. Thank you all the participants once again. Thank you for joining the conference.
Thank you.
Thank you all the participants and session chairs.
Thank you, sir. Thank you so much. It was very
Thank you.
fruitful.
Thank you.
Thank you.
Thank you, ma'am.